Welcome, everybody. My name's Elizabeth Thompson. I'm the producer of the Sustainability Laboratory's inaugural conversation series, and it is really great to see so many of you joining us from all over the world here in our Zoom room and also on our Facebook live stream. So this conversation series has been launched as a means for the Sustainability Lab to contribute to the urgent need to develop new models and approaches to addressing the interrelated sustainability crises affecting the world today. Our capacity for thinking in new paradigms and pursuing creative experimentation is essential. And it's our hope that this conversation series will provide a forum for the exchange of ideas. And we are very honored to have leaders who are engaged in some of the most pressing sustainability-related issues participating with us. And we will look forward to your joining us each month through December for all of these discussions. Tonight, we will be focusing on biodiversity and why it is so critically important. We're very honored to host a conversation with Dr. Michael Ben-Eli, the founder of the Sustainability Laboratory, and renowned conservation biologist Tom Lovejoy. It is really hard to overstate the profound impact Dr. Lovejoy's career has had on our understanding of life on Earth. From his coining of the very term biological diversity to bringing international attention to the world's tropical rainforests, from developing the field of climate change biology to founding the series Nature, the popular long-term series on public television, which has influenced generations. The link in the chat is to his UN Foundation bio if you'd like to read more about his career. It is indeed a great honor to have Dr. Lovejoy here with us tonight. So before we get started with our conversation, we're going to watch a very short, a little more than 2-minute long video about the Sustainability Laboratory. And then Michael, just invite you to, you and Dr. Lovejoy to begin your conversation. Our planet is in distress. Persistent, insensitive human activities now threaten every vital component of the biosphere, including the well-being of our own species. We are faced with a choice: continuous deterioration or a commitment to sustainability. Transitioning from the current state of affairs to a sustainable basis is an unprecedented challenge. There is no blueprint to guide us. We need bold experimentation with new ways of thinking and acting. This is why we established the Sustainability Laboratory, a global platform for sustainability innovations, a catalyst inspiring positive change. In our development projects, we work collaboratively with communities to bring about sustainability-related transformations. In our education initiatives, we help train future leaders to tackle the urgent sustainability issues facing the planet. And in our research projects, we foster groundbreaking innovations in technology. This is the Sustainability Laboratory, aiming to expand prospects and produce positive, life-affirming impacts on people and ecosystems in all parts of the world, joining with others to ensure a transition to a sustainable future.
Hello, Tom.
Good evening.
Oh, really wonderful to have you. As you know by now, I'm a great admirer of your work. So I'm perhaps a little bit overexcited from this opportunity. So excuse me if I fumble a little from time to time.
Well, I'm looking forward to it.
You know, it's the usual practice in this kind of conversation to start with a very long recitation of all the great achievements of the presenter or the person involved. And I think we'd like to take a slightly different approach and start having you help us explore Tom Lovejoy before we start exploring biodiversity. So tell us a little bit about your own trajectory, your own personal trajectory. What attracted you to biology in the first place? What made you choose it as a profession? Your encounter and commitment to the Amazons, major milestones in your journey, perhaps individuals that were inspiring and critical, events, and so on.
Well, thank you. So I guess I was just born interested in other living things. I was fascinated by animals, always outdoors, looking, for different kinds of animals. And then there came a moment where my father thought I should go away to school. And the first school that we looked at was a school called the Millbrook School, which had then and still has a zoo. And I thought, wow, I really like that. So I said, this is where I want to go. I don't want to look anywhere else. And happily, I got in. But I had no idea about science. And I had to take biology in the first or second year. And I literally said to my parents, well, I'll take it the first year and get it over with. And the course was taught by the same teacher who had started the zoo. And after about 3 weeks, he had flipped my switch. And in the course of that first year, he took us through the plant kingdom, starting with actually blue-green bacteria, and of course ending with seed plants. And then in the second half of the year, he marched us through the animal kingdom. So as a consequence, before I was even 15, I understood the variety of life on Earth to the extent that it was understood in those days, and I could never get enough of it. So that set me on a path to actually be a biologist, and I majored in biology as an undergraduate at Yale. Was really interested in having adventures and going on expeditions. So I took a year off and went to Nubia in southern Egypt when they were building the high dam at Aswan, collecting plants and animals for the Peabody Museum at Yale. And then not long after that, I swallowed hard and decided I would try for a PhD. And I really had in mind studying the montane forest birds in East Africa. I was absolutely gaga about East Africa. But I had an opportunity suggested by my former freshman advisor at Yale to go spend the summer with him in the Amazon in the summer of 1965. And I never looked back because it was the largest wilderness in the world. It was 97% intact. Everything you looked at was new and different. It was basically a biologist's dream. And I'm still working in the Amazon. So great professors along the way, including Dylan Ripley, who became head of the Smithsonian, and the founder of Modern Ecology, G. Evelyn Hutchinson. And I've always been fortunate in having great mentors and people to work with. And of course, the shoe's on the other foot now, to the extent that I have a whole series of graduate students at George Mason.
Well, this is great. I wanted to ask you actually about your first personal encounter with the Amazon basin and your experience there. The reason I'm asking that is when I was a second year student of architecture, in this case, I had a chance with my own mentor to spend a year in Africa. And the encounter of a 20-year-old that I was at the time with an entirely different world that was completely unknown to me at the time was a really life-changing event. And I'm sure that the Amazon and the time that you were there was even a more dramatic kind of difference than anything else you've experienced before. So maybe you can talk a little bit about that aspect.
Well, as I said, I was besotted with East Africa and all those, I call them animal cracker animals just wandering around. But going into the Amazon, one's imagination has been working on what is this going to be like. And it turned out to be initially just disappointing. Where were the animals? It was just all this green. And then I began to see how many different kinds of green, right? Never seen so many kinds of green in my life. And then the longer I was there, I began to see some of the animal life, which spends most of its time basically hiding from the rest. So that's why it's hard to see. But it didn't take very long for the Amazon to sort of be basically the fount of biodiversity from which I could drink forever and never get to the bottom, right? And I guess the other thing I should say is that so all of my mentors from that initial biology teacher through the ones I've mentioned all felt that conservation was important, that, as Dylan Ripley said, any biologist with a conscience should spend time on conservation. So I was looking for a job in 1973, and I learned that there was a position open at a tiny organization called the World Wildlife Fund United States. And I ended up in that position as employee number 13. That's how small it was, how early it was.
But the lucky number.
And I thought I'd go for 2 years and that would be that. And then I go back on the science adventure track. But instead, I became utterly convinced of its importance. And I stayed there 14 years before I then went on to the Smithsonian.
Let's move for a minute to the concept of what's happening with biodiversity itself. We'll leave the Amazon, we'll return to it a little down the line. Could you give us a kind of a bird's eye view of what is happening? We hear a lot about the fact that due to human activity, destruction of species and habitat, it's 1,000 times what would be biologically normal. Everybody's talking about the 6th extinction, sounding alarms that what is happening is very significant in terms of the negative destructions. Could you characterize what is happening again on a planetary level in relation to the different ecozones and particular species and so on?
So I'll get back to the Amazon in particular in a minute, but basically nature is under assault and has been under assault by humanity for centuries and millennia. It's just increased in rapidity and scale. Uh, that's true whether we're thinking about uh, the Amazon or uh, some remote habitat, where the bristlecone pines live in Western North America, the oldest organisms on Earth. Uh, Everywhere it's under pressure. And the Amazon, when I first went, was 97% intact. And it's important to remember that the Amazon is actually a very big place. It doesn't look that big when you look at it on the map, but that's because of the Mercator projection, which exaggerates the size of everything the farther you get away from the equator. And there is the Amazon right on the equator. It's actually as big as the 48 contiguous United States. And it's 9 different countries. So it's huge. And when I first went there, it was 97% intact with maybe 10 million people, maybe not even that. The vast populations of native peoples have been seriously diminished by the diseases that Europeans had brought. So today, the amount of destruction in the Amazon is pretty horrific, particularly in Brazil. The Amazon is essentially 20% deforested in Brazil. And there's deforestation in every single one of the Amazon countries. So what's so important about that number, 20%, is that the Amazon makes half of its own rainfall. Moisture comes in off the tropical Atlantic, drops as rain, and then it is evaporated off the complex surfaces of the forest and transpired through the leaves and becomes rain further to the west, and that repeats itself. So the water is recycled 6 to 8 times as it goes from the Atlantic to the Andes. And that's totally dependent on the recycling that is done by the trees and their leaves. So it's been obvious from the minute that hydrological cycle was demonstrated that at some point, too much deforestation could cause that cycle to degrade to the point where there would not be enough rainfall to support a rainforest. And that's exactly what's going on right now at about 20% deforestation in Brazil, because as I was just explaining, weather moves from east to west in the Amazon. And it's now at a point where there's what we call a tipping point, where the amount of rainfall that's actually falling in the southern and eastern Amazon has been declining. The temperature has been increasing. The deforestation impact has been reinforced by climate change and by extensive use of fire. And Brazil, central Brazil, is under drought conditions right now. And I believe we're actually seeing the first manifestations of the tipping point. Now, is it over? No. Because if we're conscientious and do serious reforestation, we can bring back some of that hydrological cycle. by getting the trees to do what they're so good at. But it's right here and now.
So it's a two-way street in the sense that you impact the hydrology cycle by deforestation.
That's right, and
and forestation can correct it.
That's right, and I should also hasten to point out that when I first went to the Amazon, there was one national park, and it was in Venezuela, and one demarcated indigenous reserve, and it was in Brazil, the Xingu. Today in Brazil, and every single one of the Amazon countries, about half of the Amazon is protected. 50% of that is through standard conservation measures like national parks, and the other half is through demarcated indigenous reserves, in which the indigenous people look after the welfare of the forests, which they're very good at.
So this sounds like good news. Is that enough?
So most of those achievements I was just describing, are 10 or 15 years old. The political will in Brazil right now is pretty shaky at the top for doing good conservation, but I sense a shift is taking place.
You were talking mostly about the forest and the hydrology cycle. I don't believe that many people have a sense of the scope of destruction of species. If I quote from the most recent global outlook report, it's the average 68% decrease in population sizes of mammals, birds, amphibians, reptiles, and fish between 1970 and 2016. So could you comment a little bit about that aspect of?
So that actually is something that applies worldwide. And I think the most shocking figure is that today, 96% of all the mammalian biomass, of the sheer weight of mammals, is human beings and their domestic animals. Only 4% is left for the rest of nature. And incidentally, that is how you go about designing a virus's dream world. So it's not surprising at all that we had a pandemic flare up in the last couple of years.
We'll go back to the pandemic a little later, but it sounds that all those issues of the destruction of biodiversity seems to be driven by two human-related aspects. One is direct, through human intrusion, as you were talking about, and indirect, like other causes that are driven by human activity as well, such as climate change. And it looks that climate change is increasingly becoming an important driver in the biodiversity loss. Could you talk a little bit about that nexus, the relationship between climate change and biodiversity? Because obviously this is also a two-way street kind of thing.
So there's not a place on the planet you can look where you can't see the fingerprints of climate change on nature. And there are places where it's quite extreme, namely in tropical coral reefs, which basically don't stand up well against even brief periods of extended warming. We actually see it in the coniferous forests of Western North America, where climate change has tipped the balance in favor of the native bark beetles. So in many places, 70% of the trees are dead. So that just makes the whole risk of fire even worse. And, you know, there are a lot of things that live in those forests. There are a lot of things that live in those tropical coral reefs. There is a significant portion of humanity which lives within 100 meters of tropical coral reefs and depend on them for their livelihoods. So it's all mixed up together in a very complex tangle that we are driving by continuing to use fossil fuels and destroy nature. So people tend to forget that all life is built of carbon, that in fact the fossil fuels are just ancient ecosystems and ancient sunlight and ancient photosynthesis that's been trapped geologically and now is being released in an instant of geological time. But there also is a huge amount of carbon in the atmosphere that comes from all the things we're doing to nature around the world. So about half of the carbon in terrestrial nature is now in the atmosphere. That's a pretty shocking figure.
This is distinct from fossil fuel burning.
That's right. That's right.
Could you give some examples to that aspect?
Well, I mean, the amount of
the drivers.
Yeah, the amount of fires that go on in the Amazon are a good example. But, you know, in the middle part of our country where we had these incredible prairie soils that were 10, 12, 14 feet deep, tremendous stores of carbon in those soils, which made them incredibly fertile, and root systems of the prairie grasses that extended that far down. As we broke all of that up to turn it into agricultural fields, we did it in a pretty careless way, in the sense that a lot of that carbon has ended up in the atmosphere. And there's no need for it to be there. We got no gain for it. We need to figure out actually how to modify agriculture so that we're not losing carbon from the soils, but rather we're accumulating it, which makes the soils more fertile.
In the climate change, the negotiations, where everybody was arguing about levels of emissions and their relationship to temperatures, what are the temperatures tolerance, if you like? How much can we allow temperatures to rise from the viewpoint of biodiversity specifically? And how does it dovetail with what is happening with the commitments that the Paris Accord asks from countries?
So the 1.5 degree proposed limit was actually mostly based on what it would do to sea level rise. When finally the small island states spoke up and said, you know, don't forget about us, right? We're whole countries here. We're about to disappear beneath sea level rise. I think biological systems are at least as sensitive to that, if not more. And so there's not a place on the planet today where you cannot see some impact of climate change, whether it's, you know, in the Arctic, thawing, permafrost, loss of ice from glaciers in the Antarctic and Greenland. It's all moving quite quickly. And I think more quickly than people had actually anticipated.
And this 1.5 degree is in line with what governments are committing to today, let alone.
Well, that's what they're talking about committing to. My sense is if we knew more about 1.5 degrees looked like, we'd try and back off from that and stop even sooner.
All right. So now let's get back to the Amazons for a minute and speak a little bit about your own, some aspects of your own work and your own research there. We talked already about the big picture, the Amazon hydrology cycles, but about conservation effort, I think that you were involved with this very fascinating concept of forest and ecosystem fragmentation and trying to see whether, in terms of strategies of conservation, whether one big area or many little ones, what would be more effective. So this business of islands of protected vegetations. Could you describe a little bit that effort and what are the key understanding that comes from that research?
So in the late 60s, just as I was finishing up my PhD, there was a lot of attention being paid to what seemed to set the number of species on different kinds of islands. And a few biologists raised the question as to whether that actually didn't also apply to islands of remnant vegetation on the land, on the landscape. But interestingly enough, nobody took habitat fragmentation seriously as a conservation issue. And that's because nobody actually watched what happens. It doesn't happen all in one, moment. It's spread over time. And there I was, at the World Wildlife Fund, recommending projects to the board, realizing that unless we knew more about habitat fragmentation, we didn't know whether any of these projects would really work very well. So I used to worry about it, try and figure out ways to get an answer. And then I had this wild idea in 1976 at the end of the year that the Brazilians had a regulation at the time that 50% of any project in the Amazon had to remain in forest. And my wild idea was, quote, I wonder if you could persuade the Brazilians to arrange the 50% to have a giant experiment. And the National Science Foundation actually bought me an air ticket to go to Brazil to see whether I could get some collaboration on it, fully expecting me to fail. And basically the first morning I was in Brazil, I got all the agreement that I needed to move ahead. And so that was something like 42 years ago. And then you had to make it happen, right? An idea is one thing, making it happen is something else, which meant finding the resources, finding the people, keeping it going, dealing with the general reluctance of the university students in Brazil to work up in the Amazon. So we did a tour of Southern universities to encourage students to come be part of the project. And so here we are, like 42 years later with more than 800 publications and teams of students who are just so eager to get back into the forest as soon as the COVID restriction is lifted.
What are key findings of that experiment? There's a relationship between size of such islands and a minimum need to support a certain extent of biodiversity. What is coming out of that?
So if you think about it, a radioactive mineral gives off radioactivity and declines to a simpler state. The idea behind the Fragments project was maybe these fragments behave in the same kind of way and begin to lose species the minute they are no longer part of a larger system. And that, in fact, is basically what we have studied and demonstrated in various ways over the length of the project. And in 2003, we published a summary which showed that a 100-hectare fragment, which is like 250 acres, loses half of the forest interior bird species. The bird species that don't like to go out into the sunlight, it loses half of those species in less than 15 years.
Wow.
So basically, you're getting an impoverishment of the fragments relative to the larger forest.
Now, the idea of islands brings immediately to my mind the concept of biological corridors. And that is, in fact, one project that we worked together at the World Bank at the time, the Mesoamerican Biological Corridor. So could you comment on that concept? And is it something that is being pushed successfully around the world today?
Well, that's a really important point you raise. I mean, natural connection in the landscapes is fundamentally important. Not even just under normal conditions, but certainly under climate change, where species are going to be moving, trying to find their required conditions, and finding themselves trapped in remnant pieces of nature. So putting connections back in the landscape, maintaining really important connected areas like the Mesoamerican Biological Corridor is essential.
Now, you mentioned earlier the known countries that are involved with the Amazon itself. And obviously, all those ecosystems transcend national boundaries. To what extent are those political boundaries a limitation or obstacles to integrating ideas of conservation and other efforts?
So for the longest time, there was very little communication between all those countries, particularly about the Amazon. There isn't even to this day an Amazon fisheries agreement, which there really should be. But recently, in part because of a pact created by, at the initiative of the President of Colombia, called the Leticia Pact, and a Sustainable Amazon Initiative, which is just getting started at the Inter-American Bank, people are beginning to look at ways to make these connections and collaborations. So the Global Environment Facility started that maybe about 5 years ago, with some isolated examples. But today, there is an Amazon scientific group created under the auspices of the United Nations, led by Carlos Nobre of Brazil. And nothing like that ever existed before. So the potential for collaboration is obviously there and it's started. It just needs a lot more effort.
Sounds like you need something like the Tennessee Valley Authority there over the whole basin. But you know, that notion of islands and corridors now brings me to that wonderful concept of Edward Wilson, of half Earth, living half of the planet out of bounds to humans. What do you think about that concept? Is it possible?
So some people just, when they hear it, they just can't even find a way to even think about it. But the point is that nature needs much more set aside for it than we have set aside. And it doesn't necessarily mean that there would be no people in those natural areas, because certainly indigenous people are very good at living with the natural environment. So the details remain to be worked out. But what I like to say is, let's not think about a future in which nature is confined to some isolated, protected patches. But let's think about a future in which human ambition is embedded in nature. And so suddenly you start thinking about natural connections and things of that sort.
Now, in another area that you did quite a lot of work in Brazil is the Pantanal, which is the largest wetland area in the world. And I understand that the wetlands around the world are also under tremendous threat. In fact, the Living Planet Index suggests that 85% of wetlands in the world have been lost. Can you talk a little bit about that aspect, as well as the huge importance of wetlands to life processes as a whole?
So there, of course, is a whole portion of plant and animal life that is specialized in wetlands. The Amazon itself, in a way, is a gigantic wetland, because when the rivers flood every year, up to 20% of the Amazon is in flood state. So there's a lot of water there. And we just have tended to think that wetlands are things that get in the way. And they don't. I mean, they have very important roles to play. Coastal wetlands are incredibly important in support of local fisheries and the like. And the Pantanal, of course, is a very, very special place. I call it the Serengeti of South America, because you can see wildlife there much better than most places. In fact, it's probably the best place to go see a jaguar. There are not so many places for them to hide. And it is. It's the largest wetland in all of South America, parts of 3 countries.
So let's turn for a minute, actually, to the namesake, if you like, of this conversation today. Why is biodiversity so significant? Why is it so critical? And it looks to me like there's a number of ways you can look at it, that people emphasize different views. I mean, I like the way that you said many times that species actually represent evolutionary solutions to many specific problems. And that's a huge treasure that you don't want to lose. There's obviously the materialistic view that talks about the valuable products and services that biodiversity provides. Let's explore that a little bit.
So everybody has easily some examples of products from nature, whether it's a wood product or a fruit or something like that. But what most people don't actually stop to think about is that every species is a 3.7 billion year line of evolution. So I think one doesn't terminate a 3.7 billion year line of evolution without some very, very serious consideration. But in the course of that trajectory, every day those species are experimenting with new solutions to biological challenges that are part of their natural history. And any one of those can, at some time or other, totally transform how we think about the life sciences. So probably the greatest example of that involves a laboratory reaction called the polymerase chain reaction. And it basically operates because it takes the chromosome of whatever organism it is, and heat causes the two strands to separate. And then each strand builds its missing partner. So you go 2, 4, 8, 16, 32, and you get this rapid multiplication. And that's revolutionized diagnostic medicine. I remember flying in from Hawaii a few years back and waking up a couple of hours out of Washington with a funny kind of sore throat. And I'm thinking, well, I bet you I got a strep throat from that little kid I was with last week. And so I stopped at the clinic on the way back into town. And they said, well, we can do the test you asked for, but we're not going to get a positive. It's just too soon. You have no symptoms. And I said, well, just please do it anyway. And lo and behold, I was positive for strep throat. So I was being treated before I really had any symptoms at all. So that's part of the power of this chain reaction. And it has revolutionized science on all kinds of genetic studies. It's revolutionized not just diagnostic medicine, but forensic medicine. It is probably generated on the order of $1 trillion of human benefit. Nobody's ever added it up, of course. And why am I going on about this? And what does this have to do with biodiversity? So, when the two strands of DNA separate and heat causes them to rebuild their former partner, it basically requires a heat-resistant enzyme. And when this reaction was thought up, nobody knew of such an enzyme. And then somebody went to the National Type Culture Collection, sort of a national zoo for microbes, and inquired whether they had anything that lived in hot environments. And oh yeah, there was a bacterium called Thermos Aquaticus from a Yellowstone hot spring collected by Thomas Brock, who shared the Nobel Prize in 1993 for essentially creating the polymerase chain reaction. So that's the $1 trillion bacterium, right? That nobody would have even imagined in advance. So if you think about biodiversity that way, basically it represents just an enormous library for the life sciences. And some of the benefits come quite unpredictably. Jenner thought up the whole idea of vaccination when he noticed that milkmaids who had cowpox, which was caused by a virus, but he didn't even know what a virus was, he noticed that they tended not to get smallpox, and did the famous experiment, which is the origin of vaccination. Well, here we are in the COVID times, everybody knows what vaccination is, and most people understand its benefit. All of that came from the living library of nature. So the difficulty about actually trying to operationalize that into some kind of conservation approach is that it's somewhat serendipitous.
Yeah.
But if you look at ecosystem services, which is far better understood, so like the New York City watershed or whatever other part of nature that you're looking at, storm surge protection by mangroves, etc. It is possible to come up with some approximate numbers and work that into some kind of a national policy. So I think in the end, what we need is national natural capital accounting, in which nations keep track of their natural assets and are rewarded in some way for doing so, for managing them judiciously, because otherwise we just tend to make these decisions where somebody decides, oh, we're going to build a road from here to there, or we want to turn all of that into agricultural fields, and nobody's ever thought for a minute about the biodiversity impact.
I would think that there are also some, I don't know how to call them, psycho-spiritual importance for humans to be truly connected with nature and so forth. But another way to look at it, which comes more natural to me, I think that we are understanding more and more from the system sciences that in complex systems such as brains or societies or economies or ecosystems, it's the very complexity that allows for long-term viability and resiliency and everything else. In other words, the internal variety of the system itself is what keeps it vibrant. And here we are turning something that is highly complex into a monoculture, which is, of course, very brittle and very dangerous.
Absolutely.
Yeah. All right. I'm afraid this is so fascinating. I'm kind of running over time, but there's two aspects perhaps that we can still throw in. One is give us, we talked about the epidemics. Let's get back to that, for example, and explore for a minute the connection between, or what are the lessons from COVID-19, since this is we're still living it, to that whole concept of biodiversity, human health vulnerability, and the whole issue of virus spills from the natural host to human due to opening new arenas, new areas, and so forth.
So people have, and the rest of life on Earth have coexisted with viruses and other pathogens, from the very beginning. Many of them evolve over time to be benign. We actually have viruses that are part of our natural genome at the moment, that became part of us so long ago, nobody even knows when it happened. But we also have this penchant for disturbing the environment, which can easily cause some of these to spill over. And that's pretty certain what happened in the case of COVID. It is a known virus of bats, with known relatives that have been pathogenic in the past. And it doesn't take very much for one of these things to get going in an age where people just hop on an airplane and bingo, it's all around the world. In fact, looking at the early maps of the spread of COVID, you could actually see where the major airline routes were, including in and out of Iceland.
Yeah.
So essentially, destruction of nature is one of the causes of these kinds of things, and also wildlife trade.
Trade, yeah.
Which puts all those animals under a lot of stress, so they're even more likely to be communicable. And, we have a history of these diseases. I mean, AIDS is one of them, SARS, MERS, even I remember West Nile coming to the United States, and it was across the country in less than 3 years. So we really need to be much more respectful of how we treat nature, and try and avoid some of these truly negative impacts. And we shouldn't forget. We forget so easily, right?
I really want to turn the floor to others to ask some questions, but I do have two more questions that I'd like to try and push in the time that we are left. One is, what is your views of the international machinery that is in place to deal with the issue of biodiversity? The way it looks to me is that there's a lot of super excellent science, monitoring, research, that help us characterize the problem itself every year. There's also very good articulation of what needs to be done, but this is where things more or less stop. You mentioned earlier that you're not doing is the real challenge at the end. And it looks to me that the current national and international machinery is just not adequate to really organize the kind of effort that is required to reverse the kind of thing that we are talking about. How do you see that?
Well, first of all, I totally agree. Second, you can see the same kinds of problems around climate change. We have been slow, very slow in coming to grips with it, namely climate change, and even slower with biodiversity, which is why I've been doing this thinking about economic systems that could change the way we make decisions. And the natural capital accounting could be one of those.
Very important aspect for sure.
But setting up all those accounts would be great, but you have to do it in a way that they actually change the outcome.
And you also cannot have the kind of fragmented governance system that we have now, I assume.
Well, we've had for a very long time.
Yeah, that can be our undoing at the end. So my last thing, kind of no holding back, I call it. If you were given the task, right, to develop the global biodiversity rescue plan, two questions. What would you see as the preferred end state? What is it that we'll try to achieve? And what are the key elements in such a program? If you had no limitations, what is the key to do there?
So I really have this image of a world in which nature is dominant, and human settlements are embedded in natural systems, in which there is abundant connectivity in the landscape between natural vegetation of all different sorts. And I don't think it's impossible to do. It just needs an economic system which puts value on that. And up to this point, we simply have not had that.
Yeah.
We do these things because they're good to do, not because there's some kind of economic benefit.
One thing that I wanted to comment in relation to the possibility of kind of retracting our steps and going back to what should be right. In one of the lab projects that we are doing in a kind of semi-dry area, desert area in Israel, we experimented with an ecosystem restoration project initiative that was hugely successful and really turned a completely arid moon-like area into almost a little paradise with vegetation and birds and everything. And the reason I'm saying it is because what was the most incredible to me was how rapidly that achievement was possible once you protect nature and allowing it to do what it obviously does best, and that's connects all the things and allow them to flourish.
Well, I think it's very true. I think, they're living things looking for opportunity everywhere all the time.
Yeah.
And so if we tilt the balance in favor of nature, we'll see a really positive response.
Thank you, Tom.